Hello and welcome to today's deep dive with the design and product development team of the Swiss-based control elements manufacturer EAO and their award-winning product, the Series 9 Rugged CAN Keypads. I'd like to welcome everyone on Zoom and on LinkedIn Live. First of all, for all of you on Zoom, please mute your mics and turn on your cameras. It's much nicer if you can look at each other. Join the Q&A after the presentation, ask questions in person or post them to the chat. And of course, on LinkedIn, we'll bring them into the session. And for all of you on Zoom, please feel free to participate actively. To join the conversation, just raise your hand on the camera or use the option on Zoom. My name is Hakuba. I'm the director of the UX Design Awards and head of strategy at International Design Center Berlin, IDZ. The awards organizer. The IDZ is a leading German nonprofit design institution. We are a professional association that connects designers, design consultancies, and companies with more than 50 years of expertise. It is our mission to promote design as a driver of innovation in business and society. And the UX Design Awards are our flagship format. We judge, award, and promote the positive impact of people-oriented design worldwide. The awards are handed by expert juries twice per year. The next call actually starts on March 1st. So you can register anytime on our website to take part, So if you're working on some great experience projects, no matter if it's products, services, prototypes, or visionary concepts, we'll be glad to welcome your work in the global competition for the best in experience design. Of course, now we are in our virtual event series where we invite awarded designers and teams to talk about their UX work and to share knowledge with the awards professional community. You can join us twice a month for deep dives featuring professionals and companies and for talent tracks presenting up and coming UX designers. With our events, we invite you to discover different design approaches, learn more about product strategy and development processes, and to meet the diverse members of our global UX community. For more, you can follow us on LinkedIn or social media or subscribe to our newsletter. And now let me introduce today's award-winning project case study, the Series 9 Rugged CAN Keypads. They are designed for operating utility vehicles and heavy machinery. They match functional safety with intelligent control. They are customizable and offer excellent tactile feedback. Powerful LEDs illuminate the control symbols, and interactive halo rings actually help guide the users, and this is what we'll be also talking about. The jury handed the Series 9 Keypads a product award in 2021 with the following statement, and I quote, "This product, which at first glance might appear to be relatively simple, impresses with its well-considered design. Its flexibility and adaptivity provide an outstanding experience that is precisely geared to its user base. The light rings are a new and efficient way to introduce intelligence in this use case." With this, I'm glad to introduce the team behind this product to you. And actually, you're very lucky because it won't be just Stephan Hakuba, but also two team members who are joining this event tonight. I'll introduce them quickly. Stephan is a product manager at EAO Automotive in Germany. He's responsible for the development of HMIs for heavy duty and special vehicles. As an industrial engineer, Stephan looks back at more than 15 years of product management and account management experience. And he's joined by his two colleagues here on Zoom. Michael Schankin, who is the head of creation at EAO Automotive in Germany. Michael began his career as an electronics engineer at EAO and has been working in the company's automotive business field since 2007. And Dominic Burkhardt, he manages industrial and UX design at EAO in Switzerland. Dominic is a product development specialist for technical and mechatronic goods and systems with more than 20 years of professional experience. So now that I've introduced our speakers, a warm welcome to all three of you. And dear Stephan, I think you'll be starting off. So I'd like to hand the screen to you and your colleagues. take it away from here.
Thank you very much, Arke. And yeah, also a warm welcome from our side. At first, of course, I will share my screen. Just a second. So hopefully everybody can see the screen and the presentation. Then at first, a short content overview about our presentation today. Yeah, we will start with some facts about EAO, our focus markets and special market requirements, which were the basis for the development of the Series 09, the Rugged keypads. Then, of course, we will talk about the product itself, the technical features, the added value for the customer, and most important for today, some interesting facts about our design and also the engineering process of the Rugged keypads. Yeah, as already mentioned from Arke, thank you very much. I will present today together with my colleagues Dominic, UX design specialist, and Michael, head of creation at EAO. So EAO is known as an expert partner for HMI. HMI means human machine interface. And EAO, a Swiss family-owned company founded in 1947, has developed into one of the world's leading manufacturers of high-quality industrial switches, complete custom solutions, HMI panels, and interface systems, and of course, specialized automotive command and control components. With over 600 dedicated employees, EAO has a global product development, production, and distribution network at its disposal. The human touch, this is our credo. Expressing the immediate moment of interaction and making it innovative, intuitive, and reliable is our task, our credo, and at the same time, our fascination. Behind each interaction lies a need, a story, a wish, and a goal. These are just as diverse as the requirements for the operation of machines. So, of course, our target is to find always the best solution for the customer requirement. Through our 4 production companies located in Switzerland, Germany, the United States, and China, then 10 sales companies and a distribution partner network in over 50 countries, we can guarantee global availability ready on time, around the world, around the clock. Let's have a short look to our main markets. Our range of services and our expertise allow us to offer complete individual and system-based HMI solutions into our key markets. We focus on the following markets: transportation, automotive, heavy-duty special vehicles, and machinery. However, by our long tradition and many decades on the market, our products are serving many other markets and industrial applications. But today we want to focus, as Arke already mentioned, on heavy-duty and special vehicles. Within this market, we have to fulfill the most demanding requirements for our products. In general, we talk about off-road and on-road vehicles with key applications in driver's cabs or outdoor applications as well. Key requirements are ergonomics, design, safety requirements. It must be configurable, intuitive operation, a rugged construction, and reliability. Main target for the HMI is that the operator has to be full control over the vehicle or the equipment at all time. To learn more about the requirements and the needed technical key features, it is a must to learn more about the market and the applications to create a detailed requirement analysis. I will show to you some typical examples. Within the market heavy duty, a typical sub-market are the construction vehicles. The application field can be the driver's cab, and the application itself is to control the engine speed during the excavator operation. This is just an example. Of course, there are more applications. The needed function in this case is the momentary push of the button. And the required key features are robustness. That means very high impact resistance, high protection level of IP6K7. That means that the keypad must be resistant against water and dust. We need a good tactile feedback. Also, a high brightness is very important, brightness of the illumination, to make the keypad visible also against sunlight, for example. Then another very prominent example is the submarket of agriculture vehicles. Concrete, I talk about a combine harvester. A typical application could be a control unit outside the vehicle, which is needed to unloading the crane tank with a pipe. Also, just an example. You can imagine that the required key feature for this HMI is very tough. It must be extremely robust, resistant against dust, water, UV light. The user needs an optical feedback while pressing the button. Furthermore, a high brightness of the illumination is also a big requirement in this case to make it visible against sunlight. Yeah, next example relates to the market for special vehicles. This is also our focus market. And the submarkets of fire trucks, for example. A keypad is required to control the ladder. That means our application field is outside, and needed product features are also robustness, resistant against environmental influences, then a very high temperature range, resistance against water. That means a high protection level is also needed, and intelligent user guidance is needed through optical feedback of the keys. And the last example for today relates to the market of trucks and buses. A typical application could be the outside control of a skip loader. The required technical features to the HMI component are comparable to the former examples. Very rugged, resistant against environmental influences. Also the intelligent user guidance through optical feedback, and the high brightness of the illumination to make it visible also under sunlight, like already mentioned. All these typical application examples have further common requirements for our HMI. The topic of safety is very important for our customers. This is about reliability, but also about corresponding technical functions up to certified functional safety. Furthermore, it is very important to be able to program the keypads according to the individual user concept. According to the different vehicle concepts, different interfaces such as can open are required for that. Okay, before we dive in detail to the design and development process, I will share some product information and also key facts about our Rugged keypads and cursor controller. The first very important fact about our keypads concerns the illumination features, which is one of the strongest selling points for our SO9 keypads. As already mentioned, our customers require visual feedback of various operating states or feedback when a key is pressed. With the CAN interface of the keypads, or the CAN interface of the keypads allow a free programming of the key functions and the illumination features. Through a 4-segment RGB ring illumination, different options are possible, like rotating, pulsating, flushing, for example. And this makes it possible to create a user guidance that always fits exactly to the application. It is intuitive for the user, and for example, the user is guided within the operation. For example, what is possible or also inactive functions. So this user guidance is given with this illumination features. The intelligent lighting makes it possible to replace a display system, for example, wherever a display cannot be used. Please think about outdoor applications. This is a big advantage of this illumination features. Second key features is the robustness. Like already mentioned, our keypads and also cursor controls has a rugged but also very ergonomic design. and has a high protection level of IP6K7, means resistant against water, dust, and so on. Furthermore, they are very simple and modular to integrate for our customers. The customer can choose between clip-in and also screw-in mounting options. Yeah, as already mentioned, safety is very important, especially in our focus market. In addition to the general issues of the reliability and fail-safe topics, we have design features in hardware and software as well that ensures functional safety in accordance with the relevant standards. And last but not least, the last key feature for today are the exchangeable symbol inserts. These inserts are a replaceable part of the complete closed keypad, the complete closed keypad surface, and can be replaced from customer to adapt the keypad to the respective use case. Furthermore, another advantage is the replacement in terms of sustainability. After many years for hard customer use or of hard customer use, it could be that the keypad symbols may no longer look nice. In this case, the symbol inserts can be replaced and the keyboard can be used in the vehicle for many more years. This is also a big advantage. We can provide the full range of ISO 7000 symbols. This is a range of standard symbols. We talk about 5.K different symbols. Or the customer can choose for specific symbols. This is another added value for the customer because he has a unique design and also the recognition of his own system and own brand. Yeah, the combination of customer or application specific symbols and the corresponding lighting features creates a user experience that is exactly tailored to the customer's individual use case. Okay, I have shared or talked about a lot of information. Let's have a look to a practical example. I think this is also very important. In this short video, you can see a typical use case with a skip loader in the market of trucks. The first operation is to extend the supports. And as you can see, the keypad shows an optical feedback, and then the next operation step is possible. In this operation, the segment illumination shows the status of the hydraulic cylinder. Then the container set down. Return the container. Again, the 4-segment illumination option. And at last operation, retract or back to starting position. Yeah, this is a practical example. And this is a good time now to hand over to Dominic. He will show you, or he will share more details about the UX design process.
Okay, thank you, Stephan, and thank you, Elke, for your words, for the introduction. Yes, I would like to tell you a little bit about the UX process concerning this project, this 09 keypads. I suppose that your experience are mostly the same as yours. The video you've seen before is one of the results of my work in UX and usability. This is a virtual representation of a real application for our Rugged keypad. There you can actually see the main advantages from the UX point of view from the user. First, you have the Stephan already talked about. You have the visual feedback at the place where you interact with the product. We call them the intelligent lighting or the user guidance. The second is you can show procedures or conditions in small animations. You can use these hello rings as a little animation. You have seen you can rotate, you can flash, you can do everything. You can change colors. you have you can show a lot of stages or things like this. And last, Stephan already said it before, you can build compact control panels because you don't need additional display elements or screens to show something. Yes, and now on this slide, you see how we work at EAO. Normally we follow the design thinking method when we are developing new products. Here you can see a rough summary of how we proceeded with this project. Of course, with several loops, as Michael will tell you in more detail afterwards. But from the UX side, it was very important to talk to users from the beginning and to try to capture their needs. So you see the idea is born, and then we want to bring something who is smart in the interaction, who has modularity, and for this special vehicles area, who is very robust to all conditions, outside conditions. Then the main part of the design thinking process is the research. We have to learn about the users, how they work, how they interact with their products. You have to talk with people, and you have to show how they work. And also the context is important. Also, where you put in your product, what's the environment of this. And Stephan talked about all these technical things, but my part of the job is more to be like the user who have to work with this product. And then you see research context, some ideas, how you can go with this product, how you have to use it, what's good, what's not good, what could be a good idea, and so on. And then we try to build up some prototypes, and then, we always try to add a value for the user. And now I think we have reached a good product with this intelligent illumination, with the compactness and the sustainability, how Stephan talked about with the interchangeable buttons. Yeah, and at least we started with concepts and we ended with a real product. You can go on the next slide, please, Stephan. Yeah, here you see how we proceed with the implementation or connection to an application. Here you can see the workflow. We also used it for this animation you have seen before. It always starts, it's my job, when we see an application, a real application, we go and try to put in our product and to start with a concept, mainly with a storyboard from the user's point of view. And so we try to capture each step I have to do, and also to show what could be the optimal illumination animation for the single step I go. And then in the second part, so second step, we build up click dummies. These are very, very low budget prototypes, and you can, but you have the possibility to show a real application. You have a low budget, you can put this in an animation program, and then you can interact with our keypad. This helps a lot to understand the functions, but also to show it to the customers or to the users how it works. And so you can you receive automatically a lot of feedbacks, and you can go through a next loop and then build it in the application. Yeah, then we can go on the next slide. Yes, and yeah, in order to offer the user even more flexibility in the future, we are in the process of collecting further customer needs and inputs on the current product version. how you had seen it before, or you see it here on the right side, this 6-button application. And we will bring the customers more flexibility. And here you see some ideas from us, how we can go further with new products. Maybe we will have in the future one single button application. So we have more flexibility to put in a design of a car or of a hood yes, things like this. Yo, that's from my side. I'm at the end. Thanks for your attention. Now I would like to pass on to Michael Shankin. Thank you.
Thank you, Dominic. So as you all may know, the first design of a product doesn't always correspond to the final product. So that's why I want to say some words to the engineering and development process we went through regarding this product. In the beginning of this process, there was a product idea. We wanted to create a product or a product series for the heavy-duty special vehicle truck and bus market. This product should consist of push buttons, rocker switches, and joysticks. And all these functions should be interchangeable in one product. By the way, this product should be robust. Sorry, too fast. This product should be robust, modular, and compact. And one of the main functions of this product should be the extensive illumination features regarding the symbol and halo ring illumination. Dominic and Stephan already mentioned it. So in the first step, we classified and weighted all the features I mentioned before against each other. And we found out that not all these functions could be put into one product. So that means we made a requirement analysis, made concept engineering, and we found out that it wouldn't match in one product. So we had to split in the first step one product where all the functions could be interchanged into 3 different product lines. That means we decided to develop a push button keypad, a rocker switch keypad, and a keypad with an RCC joystick controller. This was the first step. In the second step, we started with simulations and prototyping these second design step regarding the most important product features. We concentrated here on the robustness and the illumination of the product because these are the main features in our opinion for this product. You can see in this table here the 3 steps we used. At first, there was a design, and regarding the robustness, you can see the design of one push button here as an example. Then we did FEM simulation of this design, and you all see this red color in this simulation picture. That means there is a really high material stress in this material while pushing the button, which could lead to a damage on the button in the field. This was tested on a prototype, and as you can see on the picture for the prototyping, there is a crack in the material. So the simulation was right in the first step. We also made simulations regarding the illumination. Therefore, we simulated the thermal dissipation on the PCBA because a lot of light causes a lot of temperature. And if a PCBA gets too hot, it will get damaged or it will die, in short words. So we did a simulation of this design, and we found out that there will be possibly be a temperature of 250 degrees Celsius on this PCBA. And normal electronics won't survive this for a very long time. Also there we did prototyping to see if the simulation was right, and yeah, we found out the simulation is right. So we saw, okay, the first design was a good design, but we have to redesign the product in some steps because it won't work in reality. So we did several engineering and simulation loops and found out that the product can keep the design, but we have to move the halo rings a little bit, and we have to make the product a bit larger. After we did these several loops and found the final design, we did another simulation and validation loop again. you can see the same table as before. We have the new design of the button. We also did a simulation again while pushing the button, and now you can see there's no red color anymore. It's only yellow. So the material stress is not so hard as before. And also the PCBA was redesigned, and we also did a thermal simulation again. And there you can see you can't read the numbers which are written there, but we are only at 120 degrees now, according to the simulation. And although the heat dissipation over the whole PCBA is much better. So we said, okay, that will work. We went to the serial tools because we did verify in the prototyping loop that the simulation is right. And now you can see on the right column that we were right. The prototyping of the serial ports showed us no damage anymore on the push buttons, and also the PCBA won't get so or isn't getting so hot anymore. So this design worked well. So at the end, we went through these 3 loops. That means we had a design at the beginning. We did a requirement analysis, concept engineering, as you all know, according to a V model. We made the second loop with a new design and several another simulation and engineering loops, and we ended up at this really great product. And all the time with all the simulation loops and also the design loops, the customer was in the loop, because if you make the product bigger or you split it, you have to talk to the customer, and also the customers found out that the design at the end is much better as the design at the beginning. From the side of usability and visibility. And that was, in short words, the process we went through in engineering here.
Okay, thank you very much. Also from my side, yeah, this is the end of the first presentation. So thank you very much from our side for your attention. And yeah, I will hand over to Arke again.
Well, thanks so much to all of you, Stephan, Michael, and Dominic. And maybe you can turn off the presentation exactly so we can see each other in the face. And again, everybody on Zoom, just raise your hand on Zoom and ask your questions directly, so I don't have to read them. It might be much more interesting for you also to interact directly. But also for our viewers on LinkedIn, I would like to start off and quickly brief or like map the application field a little bit, because I believe that most people, me included, aren't too familiar with the specifics and user demands in your field, which is very specialized. And again, the keypads are a very specific solution for a very certain use case. At the other hand, I understand that the keypads may be used in very different applications, right? So in trucks, construction machinery, special vehicles, even public transport buses. So how did you actually address the different needs in different use situations? Because is it the same product that's in every application?
Yeah, it is nearly the same product. That was also the reason that I want to show different examples to you. The example of the combiner, the example of the truck. Of course, every sub-market and also every application field is a little bit different. But we tried to find out the typical features and also the typical needs of the customer to combine it in one product. But of course, this is very rugged. It is heavy rugged, as most use cases are outside of the car, and we already work on in-cabin solutions, special in-cabin solutions. At the moment, these keypads can also be used in-cabin or cockpit solutions, of course, but the main application is the outside field.
And I understand they are very modular. So when it comes to application or like the functions that a driver needs in a bus, let's say, it's completely different than a truck, right? So then the Rugged keypads are modified. It's not just one fixed product, correct?
No, not exactly. The main product is nearly the same, but as already mentioned during the presentation, we have different possibilities to adapt it to the typical use case. We can change the symbol inserts. We can offer to our customers a lot of different symbols according to the ISO 7000 norm, or customized symbols to make it unique for the customer use case. And the next possibility, and this is one of our strongest selling points, like already mentioned, it is possible by CAN interface to program this keypad to define the best functionality for the customer's use case. You can program the illumination features, you can program the key features, the functionality behind, and so on. But of course, the mechanics are every time the same.
Right. So I think that this connects to a question from Lars, who's here on Zoom. I mean, Lars, you're very much invited to turn on your camera. I just basically joined the conversation. Otherwise, I'll ask you a question. And Lars wrote he's interested in the actual user research he did for the product development. Could you describe your research approach to gather insights and your prototyping evaluation, actually? Maybe this is also for Dominic. Sorry, Stephan, I didn't want to interrupt you.
No need to say sorry.
Okay.
Yeah, Dominic, it's your turn.
Okay, no problem. Yeah, it's okay. When we start with a project like this, then it's important in an early stage that we have feedback from real customers or users. And often we start not with a functional prototype. We start with paper. Everybody here knows it. Every UX designer do this every day. You start with a rough concept, with a sketch. You put on some post-its, and then you go and say and show this and say, when you put here, then this disappears or this happens. And I think when you take the design thinking process, you are able to find out a lot of things in the early stage with a low budget, and then you can really build a clear concept, and again you can go with this concept further. And then in the second step, you can go and you make some easy mock-ups. You can put in a Raspberry Pi or something to make the electronics. And then you can go and you can show something. You can show how these rings could work, what could be okay or not okay. Maybe our first idea was only a flashlight, and then somebody says in an interview or in a workshop, hey, maybe it could be cool. Then if we can change this, not only a flashlight, maybe also a rotation light, and maybe we can even have more segments than only one, and so that we can make some rotation things, or we can change the color in the same ring. Maybe you have seen the video, and so you can also put some distance things. You can go and start. You have a ladder who goes to a wall, and then you can say, okay, I want to know the distance when I'm near at the wall. So you can start, and then it starts. You have green, then you are 2 meters from the end point. Then you go 1 meter. You have orange, and then you are a little bit from the wall. Then it's red, and then you know I have to stop. And so you can imagine thousands of elements you can put in this keypad. Only with this, we call them the intelligent illumination. You have, and so this was the process. So, and then which each step you have something, you test it, you see it, and then you have more ideas what you can do with it. And so it's a little bit the process of all this, but mostly it starts with an idea, with a rough sketch, and then it goes on.
So is it right or correct to say that it was more of a qualitative, iterative trial and error, of course, based on solid knowledge approach, or was it more, let's say, based on data and
No, it's a pragmatic approach. Yes, it's really a hands-on approach. You have something, you go, you show, and you receive the feedback, so you receive input, and then you go further. You make the next loop, and you go out with the new concept, and then so you try, or you have several concepts, and you go and ask and show them to different peoples, and then so you see what are the really the needs of the users. So you can go in, I think so, in the right direction. And I think with this product we did a good job, I think. Yeah.
So it's a very hands-on approach, which really matches the buttons, I would say.
Yeah.
Maybe to give you an example of what we did regarding user experience, you all saw that we have as applications, for example, fire trucks or garbage trucks and so on. And what we did here is we went with our prototypes to the manufacturers of these vehicles, talked to them, got the feedback from them. And what was also important was talking not only to the manufacturer of these cars, we also were talking to the guys that are using this in the field, for example, the firefighters or the garbage truck drivers and so on. And the interesting thing is that you always get a different feedback from the user than from the manufacturer. And that is what you have to combine, and then the product will become a great product.
Yes, I think this is the most interesting part. We could probably spend half an hour talking about anecdotes, what manufacturers think their users need and what they actually need, right? This is the old problem. But also Lars asked another question which adds on to this. How did you actually evaluate prototyping? When you prototype, how did you evaluate the results? Is there a systematic, method that you used?
Yeah, the development process is working along the V model. That means you first do the requirement analysis, then you do the verifying. And if you did a prototyping, we are using different technologies for this. And if you have the simulation results, then you try to verify these results exactly on the prototype. And for example, for the thermal simulations, we used a simulation tool, that's clear. And then we used the infrared camera to verify if the simulation was right. And these prototypes had different stages. We did simple prototypes, as Dominic mentioned. We also did prototypes from tools which were near series tools. And these all, as I mentioned before, went along a V model and always in stages. So always design, simulation, verification, design, simulation, verification, always in these 3 steps until we reach the final product.
And furthermore, we also work close together with some lead customers. Of course, we have some customers which we integrate in this prototyping process for testing and receive feedback, and then happens what Michael already mentioned.
Right. There's also a question about why there are 6 buttons on the panel. Is this a limitation somehow, or is it by choice, maybe? Or does this match actually the use flow in the scenarios where the keypads are used?
This is a very good question. Of course, many customers ask also the same question. With the Series 09 keypad family, we stand at the beginning, and of course, we want to go further in our development of new variants. For example, 8 push-button variants, also smaller variants. This could be interesting, especially in-cabin use cases. But we started with 6 push buttons because we learned from our customer that most applications need 4 to 6 different functions and different push buttons, and that's why we started with a 6 push button keypad. This is the reason. But as already mentioned, we will increase our product range in the future.
Right. So this is basically the foundation for the product, and
Yes.
Based on your user analysis, I understand you understood that there isn't much more that is needed in most scenarios. So to reduce also the choice can also help, right?
Yes, right.
And
And as already mentioned, it is also possible to combine these keypads. Of course, 6 plus 6, we can also provide 12 keys. Please think about a dashboard or an armrest in a combiner, for example. This is also possible. But of course, our customer asks also for other configurations, and so we decide to go further with our development of new products.
What we found out, you were right, that some customers are also able to reduce their number of buttons because of our illumination features, because you can make the halo ring yellow, for example, for the first function, and if you have to start the process, then you can switch to blue or something like that. Where you needed 2 buttons before, you can use 1 now, and yeah, so sometimes customers also reduced, and 6 buttons is the best of all for the beginning. Let's say it like this: 4 are too less, 8 are too much in some examples. So we started with 6. Yeah.
Well, I was actually wondering whether there's also a limitation in because you only have buttons and colors, but now there is a limitation of choice that is pre-built somehow into the system, right? But now it seems that it's the other way around, that actually you added additional layers of visual feedback, which made some applications obsolete that were there before and that were using space, right?
Yeah.
Right. There is another question. Okay, from Vardui, right, from LinkedIn. Vardui asks, do buttons work only by human touch, or as these pads are placed outside, how have you managed if the car crash, or how did you manage car crash cases, where other cases where non-human physical object will press it accidentally? Is that an issue?
Yeah. If there's an accidental use in the keypad, at first there's a debounce time. That means if you push the button only for a really short time of some milliseconds, the keypad won't recognize this, because a normal operation is, in normal cases, is longer than 20, 30, 50 milliseconds, something like that. And that's what the keypad recognizes. The other things, if the person, for example, or a tree or something like that is laying on the keypad, this can also be detected by our keypads by an button stuck detection, where the keypad is sending out a kind of error message which says, okay, the button is pushed longer than it's intended to be. And so the ECU or the car can work with these signals and maybe notice there's a fail detection or something like that, yes.
Right, so there is also an instance of sensorics and touch sensitivity to the panels?
No, it's only done by time. We are only monitoring the time when the button is pushed. There's no capacitive sensoring inside. And
do you have other systems? What did you build in to avoid failure or add safety for users?
Yes, we have. This is what I already mentioned during the presentation. We have we had designed in some features, hardware and software as well, which relates especially to the safety topic. As we already learned in the presentation, some customer need the certified functional safety option. Or the non-certified functional safety option, but it is necessary that we can offer some safety feature and also diagnostic features of the keypad. For example, temperature, button stock, what Michael already mentioned. So this is very important for this market.
I think we can talk about details here. That's our know-how. But like Stephan mentioned, we have some features inside. We are monitoring the temperature of the keypad. As I told you before, we are getting really hot because of this bright illumination. We are monitoring the voltage, for example, of the car. We have a button stuck detection. Such features enable the customer to see if there's something wrong in the system. And this is not, it's only done inside, but we are always sending out all these messages, how is the temperature of the keypad, how is the voltage, and so on. So the customer system is able to detect a failure.
And in terms of actual use of the operator, so there is basically the visual feedback if something goes wrong, but not only, I think.
There's no, we as a keypad don't give the customer feedback if there's something wrong. We are only sending out the message to the car, for example, that there's something wrong. But the system of the car has to decide if there has to be a feedback for the customer. That's not up to us, because we don't know the application behind what the customer wants to do with the keypad. So this is up to the application. We are providing this. Maybe the halo ring can start blinking or turn to red or something like this, but we are doing this active.
Right, you add actually guidance, which I found very neat, is that the halo rings actually illuminate to show which buttons can be pressed in order to operate safely in machinery. So they actually indicate that which could be the next steps of operation. So that actually adds a lot of safety, I guess, in everyday use.
Yeah.
There was this question also from Lucas. I find this very interesting because he said, your core customers are actually machine manufacturers and car manufacturers, and they can actually personalize the pads. So can you explain a little bit how which possibilities there are for your business customers actually to adapt the pads to their brands, to their vehicles?
Yes. For normally the possibilities are limited. We talk about a standard product, and of course our goal is, or our target is to sell this as a standard product. We have different possibilities for customization, like already mentioned, the symbols. Then of course the symbol inserts itself. It is also possible to have a red for functional or a safety related function. For example, it is possible to have a red button, not only the red symbol, a real red button. And yeah, of course, EAO are also known as a company which provides customized solutions. This is also possible, but in this case, we talk about a real standard product.
Did you actually also provide a software suite for customization? So is there a UI that comes with a panel for clients, for business clients? Or how does it work? Or is this part maybe of the UX of the system?
Yeah, of course, it depends on the system. It is we are in very close contact with many customers, and of course we have the requirements for customizations also, not only to go in the software, also to change the hardware. We have to check it for every case. Of course, firmware or software modifications are possible, but this is not our target. Our real target is to sell this product as a standard and show the customer the possibilities for his own customizations. This is what Michael already mentioned. We provide the solution and the options, the use case and the user guidance. This is part of our customer, but we work close together to find the best user experience, user concept together with the customer. And also Dominic is very close at the customer to find the best concept within the cockpit and within the complete user concept.
Right. You talked also, excuse me, about sustainability, adding of sustainability that you achieved. Can you further tell us a little bit more about it? Is there some innovation in the materials too, or repairing, reusing?
To be honest, in our market, it is nearly not possible to use other materials. We need very rugged materials and also very common materials, robust plastic, robust silicon. This is unfortunately not our focus for the sustainability. But as I already mentioned, we have a high quality product, and so it can be used for 10, 12, 15 years in a vehicle. And when it looks not nice, for example, the symbols are scratched or something like that, then it is possible to change and make it fit for the future. This is our our content for sustainability.
Right, so there is a replacement possibility, and the electronics continue to live.
Of
right?
course, the
That's
electronics
the
continues, the housing, the plastic parts continue.
And of course, also the lighting system can be updated, right? So you have the ability now to actually take a step beyond the physical and add also the digital possibilities that are there for updates, for changes.
Of course, it depends on the customer car system or vehicle system, yeah. But of course, this is also possible to find new functions in the same vehicle to get an update for the vehicle.
Right. Yeah, actually, I thought that it's a very constraining industry, probably, with a lot of safety concerns, predefined measures. So it's not easy to be very innovative there, and you succeeded in to be so in the details, which is absolutely great. And this is also why the jury handed an award to this product. I'd like to open up a little bit, step away from the physical product itself, because like exactly in this field, I mean, a lot is also developing, most probably. I'd like to ask you which technologies could maybe in the future become important. What do you think in your industry? Is it like gesture, voice control? We know this from private vehicles. Haptics.
Yes.
What are you looking for?
Yeah, this is a very good question. Yeah, EAO stands for electromechanical components, and also the fascination of the real touch between the user and the machine, for example. And it is not in our roadmap at the moment to provide gesture control or something like that. But this is the reason for that are our focus markets. Of course, you're completely right. For private vehicles, for consumer cars, there are other technologies, touchscreens, gesture control, voice control, something like that. In our focus market, heavy duty and special vehicles, normally in the outside applications, also a display is not possible to use. And this is our chance for our products. Of course, we want to increase the product range with different options, and we want to improve it step by step. But new technologies, for example, like gesture control, is absolutely not common in our market.
Okay, so there is muted. Exactly, I noticed at the moment. It sometimes slips also to me. So there is no danger of a zero UI that comes across your way anytime soon.
It is hard to answer. We know the market changes and changes very fast. But our focus market, also transportation, is a very safety relevant market, and so some technologies, for example, also capacitive touch technology, are not possible to use in most use cases. We have a look to this development on the market. Of course, we have our own business development department, which has a detailed look to the market, and we will see what happens in the next years. But of course, we are also prepared if the market changes.
Yes, and there is definitely some stuff you can't talk about now openly. There was actually a very funny question I found, like these buttons look a lot like game controllers. So was there an inspiration in gaming, or maybe added on to this? Are there fields beyond your core business fields that you can now tackle with this invention and this solution?
I'm not sure, Dominic. What is your opinion to this question?
Yeah, I think it's a good thing when you talk about. Yeah, it's like game controller. Yeah, even the illumination features are you see it also mostly in games when you start games, when you push the button longer, or short, you have different things that happen on the screen. And we also can do the same thing on our buttons. So but we don't have the illumination ring at the flat screen. We have it on the product itself. And that's, yeah, that's right. That are some things we look in at other products, how they solve something, and how you can take the good things to make a good solution. Michael talked about, we have also a solution for change speed with only one button. And you can pre-select if you tap, and when you are on the right mark or the right speed, you can push 2 seconds, and then the system recognizes, okay, you want to change from low to high speed, something like this. And we can also play with the buttons. We can do like a double click, so you click twice, and then you have another signal or another tool that's open when you push it 2 seconds. So we have even the possibility to use each button for more than one function, and so it's very, very flexible at the end. Yes.
And we know gamification is one of the big trends on the market, but gamification means to make it simple, as simple as possible for the customer and for the user. And this is what we already mentioned. The keypad function is free programmable by the car manufacturer to make it more easy and as easy as possible for the user to create a real user guidance. This is our gamification.
I think it gets as best as it can. I mean, you have the possibility to actually bring in, through feedback, lighting, and more flexibility, but also a touch of emotions into something as simple as keypads in a very professional, hardcore working environment. So it was actually one of my questions, where it's possible to bring in emotions into such a technical field, and I think you get very, very close to this. So thank you very much. I don't get any questions from the audience, so I think that you have done a perfect presentation. There is no questions at all left. Thank you very much for your inputs. Thanks for taking your time, and thank you much for so many insights that you shared with us. And I would also like to thank to everyone who joined us today. And I would love to welcome you at some of our upcoming events, especially a very special one that is coming up on the 1st of March, our virtual award ceremony, where we will present the first round of the UX Design Award winners in 2022. Hop on to our website and follow us, get our newsletter, and tune in again on the 1st of March. We'll be very happy to see you there. And also on March 9th, we will feature Zena, another award winner. It's a digital wallet and payment app designed specifically for the Middle East, a region where most people are still digitally unbanked, which we wouldn't really think. So check out our awards website, as I said, to register. Check out our social media channels. And of course, for a recording of today's event, if you missed this. It's time to say goodbye for now. I wish you a lovely day, morning, or evening, wherever you are. Stay healthy above all, and stay safe, and see you soon again. Bye-bye. Thank you to Switzerland.
Thank you.
Thank you to
Bye to all.
Bye-bye.
Bye-bye. Thank you very much.